Okay, so we're going to have a bit more of a look at a few more complex materials. So what we're going to do is a decal. This is an emissive decal, and it's not emissing properly for some weird reason. I think that's just an Unreal Engine issue. But this one's we're going to use for one material, which is the one I'm going to show you next. And then we're going to play with some more complicated render to texture based ones. So, yes, our sort of blood thing. So we create a master material again. Now, I've created a couple of textures, but actually I'm only using one of them. This is being used as a grayscale image. Essentially, you can create your own textures or just download them from the internet, so I'm not going to cover that part of it. This is the first person template, and there are a couple of things that I will show you. Just I will go through the material first, and then I'll show you the setups for it. So the actual material node is set to deferred decal, decals being sort of projected textures that will sit on top of other materials. It's set to translucent emissive. You can't, it will actually complain if you set it to anything else. So, this is what it wants. For some reason, the emissive isn't quite working properly. But I'll take you through the shader first, the actual material setup, and then we'll look at what's going on. So, emissive color is meant to be the color, obviously, of the object. It should be more emissive, i.e. it should actually glow a little bit. Something in the deferred decal system in Unreal Engine 4.18, which is the version I'm using on this, is a bit of a problem. So let's have a look at the inputs. So we've got a texture parameter here called splat texture. So if you want to do a texture, one way to get a texture node is to just drag a texture into the workspace from your normal content browser. Now you can then convert that to a parameter like we did for the parameter for the other material and give it a name, which is what I've done here. So we're using this texture essentially as a grayscale image. This is just temporary. I'm not going to leave it like this. We're going to multiply that with another calculation. We're then going to multiply the result of that with another parameter value, and this parameter is just a float which is called light on. So again, if you want to add a single digit sort of value, a single float, you press 1 on the keyboard, you click on the workspace, and that'll give you a float. You then convert that to a parameter and call it what you like. So we're using this to essentially switch the light on and off. And I'll show you the code that does that. So essentially it's saying the input value is multiplied by whatever the result of the calculation is and fed into the opacity. So essentially we'll feed a 0 into this to switch it off completely. Opacity being whether the thing's visible or not. So the node itself is fairly simple. We need to feed it a color. We need to fill it like the opacity value for it. So what are we going to do with the opacity? Well, here's the thing. If we look at the actual material here, what we want is a few parameters, and this is why the parameterization thing is really important. We want a few parameters to feed in this case, the flashlight. So the flashlight position, flashlight direction. Now, I'll show you in the blueprint where this is coming from. So the blueprint's actually going to do this sort of feeding the parameters into it from your first person character. So what we're doing here is a simple calculation. We're saying from the world position, which is the pixel, the actual world position of the pixel, we subtract the flashlight position to get sort of a direction vector. We normalize that. We then do a dot product between that and the direction of the flashlight. So we're essentially saying how close is this pixel to the center of the flashlight beam. Now here's another sort of simple thing. So mathematically the dot product's going to give us between -1 and 1. based on the angle between those vectors. And what we really want is a 0 to 1 value. So what we do is we add 1 to it, so -1 to 1 goes 0 to 2. We then divide by 2 or multiply by 0.5 to get it 0 to 1. So that'll give us a 0 to 1 value based on the angle between those two vectors. Now here, I'm not actually doing this mathematically correct. I'm just crushing those values essentially to get a more focused kind of area. So this stuff is the kind of thing that you should be improving on in your shaders when you're doing the maths for them. I've just created a new parameter here, again a floating point parameter, called it light fall off. So this power node, essentially it does a sort of raises the value to the value by the value of the exponent. If you actually look at like what power nodes actually do, in essence they're kind of crushing the values, so they're kind of making them more extreme. In this case I'm using it to focus that angle, because obviously this angle here is going to give us between 0 and 1 over 90 degrees, and I actually want it more focused, so I'm using that as a sort of light fall off focus beam kind of thing. But actually it's a little bit rubbish, and we probably want to do some better maths for this. So we're taking the angle of the light towards a pixel. We're saying, okay, so that's the angle that we're forming away from the beam. We're multiplying that by our opacities to sort of get where we should draw pixels or not. And then we're scaling that by whether it's on or off, essentially. And we're feeding that into the opacity value. So once again, if we actually look at it, this is if you look at the sort of center of the screen where the red crosshair is, that exponent is changing how far away from the sort of center we're able to draw pixels. And I added a little key press thing that will allow you to focus that in. That's what the sort of exponent thing's doing, really. And at some point the maths breaks down and it just switches everything on. So, you know, the maths isn't correct there. We can fix that at some point, but it's just a quick test to get it working. Okay, so how do we get that actual material working? So there's a few things. First one is, let's show you how the decal's set up. So the actual blood spat itself is a decal, and a decal is so in this case I created an empty actor, I added a decal component. The decal component has a material on it, so we create our material instance and put it on the actual decal material. Let's go back to that. So I've created a material instance based on the master material, put that on the decal. Now if we, so if we look at one, kind of hard to see it, but the actual blood splat itself, if we look in the viewport, is just essentially a volume that says the decal's going to be projected through this space. So you can move them around and those kind of things. Weirdly you can't see the box for that, but normally you can see like a projection cage kind of thing. What you want is your decals to be as close to the floor as possible, so you don't get lots of the one thing I will say is decals generally project through all objects that they're like on top of, so you want your decals to be as close to the floor as possible without having Z fighting, which is where the sort of depth values kind of start flickering. So one way, let's see, we'll just change the blood master. We'll just switch it. We put oh no, I won't bother with that. I was just going to say I'll show you sort of how it normally looks, but okay. So we've got our blood splat actor with a decal component on it. We've dragged those out into the scene. There's actually two of them. normally you can see, let's just create a new actor. Blueprint class, actor, test decal, and we create a new decal component. You see by default the actual sort of decal projection is sideways, which is not what we want, so let's just, I think it's this one, 90. Yeah, I think that's right. Well, we need a new decal material, so actually let's make one while we're here. New material, let's call it, oh god, what are we going to test decal, and, no, let's go with the convention, m_test decal master. So we need to set our decal to deferred decal. Let's make it a can we do a master? No, we can't do master. Normal, no. Translucent, no. Yeah, see, it'll complain if you can't do any of these, so we're going to make it translucent emissive. Okay, so emissive color, let's just do a red. Okay, well, it turned out quite pink, but there you go. Opacity, we're going to stick 1 in there, so just give that a value of 1. We could probably, no, actually, let's do that. Instead of that, we're going to drag the splat texture in, just so you can see what that looks like. We're using the red channel out of that for the opacity. Yeah. So we can apply this onto our test decal. What did I call it? I've forgotten. m_test decal master. We shouldn't probably put the master material on it, we'll put an instance on it instead, but hey. And then we can drag some of these out into the world, right? So that's without the sort of mathematics for the angle check. Yeah, they're just sort of stuff that'll project out. Now, if you raise these things up, what you should notice is that decals by default will project onto everything. Now you can switch things to say don't project decals onto me, but just be aware, what you want is you want your decals to be as close to the ground as possible, essentially, if you're going to put them on the ground, so that when you move them around, they're not necessarily on the top of everything. Still a bit sort of cheesy, but there you go. And you can tell your characters to avoid decals and all that kind of stuff. Yes, so that's a simple decal, and that's the sort of modified one for our blood stuff. So you see here the problem is that we become pink because the decal's projecting onto us as well, which is not what we want. We want something like this. So yeah. So anyway, that aside, so we want our blood splats to have this instance material on it. So we're using that material instance with the blood splat actors, and the blood splat actors are in the scene. So what do we do to actually switch them on? Well, there's the thing. If we go to first person character, thing is, can't remember. Nope. Let's go to here and find my character. Okay, he was around there somewhere. So there's a couple of things I'm doing. Let's just show you the setup. So right mouse button, when it's pressed, I set a bool to his drawing, so you can just set that in your blueprint. And then in the tick, forget about this node, this sequence node, it's just so I can do something else as well. I'm saying is drawing, if it's true, and let's just zoom that a little bit so I can see it all. We're saying get all actors of class blood splat, so that's our decal projecting actor. We're looping over them and we're saying set some vector parameter values. So that's the inputs to our material, right? Keep saying shader, but yeah, I mean, it's the material that creates the shader, so it's fair enough. So what we're saying is when the light's on, loop through all of the actors that could require this sort of input values and pass the values into them. So what we're passing is the camera's position. Now you'd normally get your light, your torch or whatever, and pass the world position and forward vector from that into these values. So I've created my flashlight position, flashlight direction, light angle, light fall off, and that value that switches the light on or off. So, to get those nodes, what I've got is, so this is our blood splat actor. Now I've created in the event graph of this guy, in the begin play, I do a thing called create dynamic material instance, and this is important. What it means is that it's creating a copy of the material that it's already got and making it dynamic, making it modifiable in code essentially. So I'm creating dynamic material instance and returning the value of that into a reference, which is vector material instance. Yeah, so you need to create one of these variables, store the return of this one from your decal. So we take our decal node, drag it into here, do create material instance from it, store the value of that new dynamic material. So the dynamic material is the thing that's being affected. And in our first person, we're looping through all of those actors. We're getting the material instance dynamic from them, which is why I call it mid, and we're setting these parameter values. So we've got a bunch of parameter values here, and we're just going to set them into that material. So that's how you pass parameters into a material. You can pass whatever types of parameters you like as long as they're valid, obviously. So in this loop, we're saying if the light's on, we're going to set these parameter values. If the light's off, all we really want is to set one parameter value, which is that light on value, and we're just passing it as 0. So 1 means on, 0 means off. Yeah, because it's multiplying everything by 0, which will mean 0, so you get off. So this is not the right way to do it, by the way. This is like the cheap, hacky way. Looping through all of the actors is probably a bad idea. We probably want the actual blood splat things to register themselves with another class and have that store reference to them, so we can just do a loop through that. But for now, we're just looping through every actors in the scene of this particular type. So have a play with passing some parameters in. Like, you can pass the color value in, you can pass whatever parameterization you've made for your material. So create a material and in a blueprint, pass a value into it. Don't forget you need to create the material instance dynamic, which we've done here. You could even do it in the actual object that's got the material on it if you want to be honest. You can create a material that passes in some color value that blends between two colors and does it over time kind of thing with a timeline, and pass that into your material. But just remember that this is the parameterization, right? You can create new, let's create a new 4 color vector, convert to parameter. You can convert input values to parameters and just pass them arbitrarily, right? So you can do arbitrary maths in all of your graphs here to come up with the final color values or the final, roughness, metallic, and that kind of thing. So we're going to do some more complicated stuff with a couple more materials later on, but I think that's enough for now. If you want to play with this one, let's just go through the nodes again. Flashlight position is a parameter. Subtract that from absolute world position, which is a default value for shaders, so you can get it from the list here. Normalize it, do a dot product between that and the flashlight direction, essentially scaling and biasing it in these two nodes, and then using the power node to sort of crunch that value down so it's a bit more focused. Multiply that with an opacity mask so that we only draw the pixels that should be on. We've got a mask, and then multiply that with essentially 0 or 1 to switch it on or off, and put that in the opacity value. Dead simple, and we can, you know, parameterize our color value so we can change the different decal colors if we need to, you know, red, or in this case, like I think blacklight makes blood glow bluish, greenish. So that's what I chose. You can choose your own values. So there you go. Decals are kind of useful, but I think they're a little bit broken in 4.18. They might work in earlier versions, so check that one out. But it's not a bad effect. We will probably revisit the maths for this because this is kind of a bit clunky, and playing with those exponents and stuff. Oh, just so you know, the exponent thing, I just did it here. Like pressing the different bracket keys changes the fall off value. The fall off value is passed in as a parameter. So yes, have a play with these shaders. They're good fun. Next one we'll do is the ready to texture one, which is even more fun. There's lots of stuff you can do with that. So this will give us some absolutely funny stuff to play with. So look forward to that one, and I'll speak to you on the next one.